All right, in the last video, we looked at the fat and calories in cheeseburger and added that scatter plot and regression line. Now we're going to look at a new data set that has two categorical groups to it in addition to the two quantitative variables. So we're going to end up with a two-color scatter plot here. So this is the apartment data. It represents the square footage and rent for apartments in Queens and in Long Island, New York. So there is an Excel tip here. When you go to choose more trendline options to add the equation and coefficient of determination, when you're doing this with a two-color scatter plot, you have to go through that process twice. So you go through it the first time you pick one group, and then when you go through it the next time you pick the second group. So let's hop over to Excel and take a look at this data. All right, so here's our data set for the apartments. You have the square footage, and we also have the rent per month for both Queens and Long Island. So I want you to start the first part of this on the notes. You're going to identify the explanatory variable, the response variable, what the categorical variable is. You'll have to kind of give that a name. And then there are two levels or two groups in that categorical variable. So see if you can identify those. So go ahead and pause the video and just do that part, and then I'll come back and help you get started with the scatter plot. All right, so hopefully you gave that a try. Our explanatory variable is the square footage, right? So we would think that the size of the apartment is probably some part of what that final cost is going to be. The bigger the apartment, generally the greater the rent. And then that means that I'm going to use that square footage to predict what the price is going to be per month. So my response variable is going to be the rent. And then for the categorical variable, that's where I see this Queens and Long Island coming up. So you could give this a name like location or location in New York or something along those lines. And then one of the levels is Queens and the other level is going to be Long Island. Okay, so that should get you through the first part of the notes. So let's look at making this scatter plot and adding those lines. So I'm going to highlight all three columns, and I am going to include that Queens and Long Island so that it automatically makes the legend when I put the scatter plot in here. So there's my scatter plot. Like I said, there's the Queens and Long Island, so we can see which color is which. And I'm going to go ahead and add those axis titles just to make it a little nicer. All right, so the explanatory is going to be square footage, and then the response on the y-axis is going to be rent. Right, so that's all labeled. Now I'm going to go and look at adding those regression lines. So I'm going to go to add a trend element, down to trend line, and all the way down to more trend line options. So when I click that, it asks me which group I want to use. Do I want to do this for Queens or Long Island? So I'll do Queens first, and I'll say OK. And you'll notice it opens the panel so I can display the equation of the R squared. So Queens is this blue color. I'm going to move this kind of closer to where the blue dots are. So I get an equation here of 2.2091x minus 34.315. And my coefficient of determination is 0.82, 0.83, something like that. So that seems like a pretty good predictor. That's definitely bigger than 0.5 and getting close to 1. And then what values of the explanatory variable? So I do need to focus on just these blue dots that are on here. So my smallest blue dot looks like, I don't know, maybe about 450 or so. And then my greatest one is just shy of 1500. So maybe 450 to 1500 might be about 400 to 1500. Somewhere in there is probably an okay range of values. Okay, and then it does ask for a prediction. So if I'm renting a 1,200 square foot apartment in Queens, let's see what that cost is going to be. So I'm going to go down here. I'll put equals 2.2091 times the 1,200 square foot minus 34.315. So it looks like that apartment's going to cost me $2,616.61 or so. for that apartment in Queens. And now I'm going to go through that same process with Long Island. So I'm going to click on my graph again. And I'll go back to added, I'll double click here so I can get to that added chart element. And I'll go back down to trend line and more trend line options. And this time I'll choose the group for Long Island instead of Queens. So I'll get that. And then I'll add the equation and the R squared value. Here's my other one. And I'm going to drag this one so it's kind of closer, oops, to the orange dots. Change that back quick. All right, so there we go. So my new equation for Long Island is 2.0995x minus 347.36. And this one has an R squared of 0.75. So not quite as good as the Queens, but still that's much bigger than 0.5 and close to 1. So it should give us pretty good predictions. And then the values I would use this for. So this one's a little bit tricky. I'm focusing on these orange dots. So the lowest orange dot that I would probably consider is this guy here. So 500, 550 maybe on the lower end. It's a little trickier on this upper end. I suspect that this orange dot out here that's about 1900 square feet is probably an outlier. So I could try and use this all the way out to whatever this is, probably about 1800. Or I could look at maybe stopping here around 1500. So this is an issue statisticians run into as we kind of weigh those pros and cons. So either way you chose would be fine with me as long as you just kind of explain what you're thinking. So if that's on the homework, the quiz, on the test, I wouldn't give you one ambiguous like this on the test. But as long as you explain what you're thinking, I'll read that, and as long as it makes reasonable sense for statistics, I'm fine with that as an answer. We don't all have to have exactly identical answers on this. All right, so there's your two-color scatter plot with the lines. You just need to go through that at a line process twice to get there.